A sample of 250 grams of liquid water is initially at a temperature of 80 degrees Celsius. If that water is heated by the combustion of 26 grams of coal, carbon, to form carbon dioxide, assume all the heat from combustion goes into the water. Determine the final state and temperature of the H2O. Explain the determination of the energy produced by combustion of the coal, the amount of energy used to heat the liquid water, the energy needed to vaporize the liquid water, and the final temperature determination. So, what we need to do first is balance the combustion reaction, which is fairly simple, as it is simply just carbon plus dioxide to form carbon dioxide. Afterwards, we want to find the enthalpy of combustion of carbon, which we can do so by referring to our enthalpy of reaction chart. And for our substance, we're definitely looking for carbon dioxide. Well, carbon or coal. And we can find it with the delta H, which for our case is negative 393.5, which is what we have here. And we also need to find the molar mass of carbon, which by referring to our P table, our periodic table, we find it to be 12 grams. So 12 grams of coal, carbon, releases 393.5 kilojoules. So 26 grams of coal / carbon releases 852.58 kilojoules. And we can find that by simply multiplying 393.5 times 26 divided by 12. So what we know is that the heat capacity of H2O is 4,184 joules, or 4.184 kilojoules. We can find that by simply researching it on Google. And we know that the mass of the water that we have is 250 grams. And the initial temperature of the water is 80 degrees Celsius. So in order to find the final temperature of water, what we do? Well, in order to find the final temperature, we take 80 degrees Celsius, which was the initial temperature, equals 852.58 kilojoules, which we get from the amount that 26 grams of coal releases, divided by the 250 grams, which was the mass of the water that we had initially, times 4.184, which is the heat capacity of water. And in doing this, we get 0.815. Then we take this and we add it to 80 degrees Celsius, which was once again the initial temperature of H2O, and we get 80.82 degrees Celsius. So the final temperature of water is 80.82 Celsius, or 353.97 Kelvin. So the final state of water is a liquid. And we know this because the boiling point of water is 100 degrees Celsius. And as we can see, we are still not close.